Welcome to my project on the NYC Street Tree Census Trees Count Data Jam Challenge. Here is a quick overview of the website I created using some basic data analysis, the Cartobee platform to create a mapping portal dropdowns for different thematic maps, and data download. All my code is on GitHub, and how I created such a site and performed data analysis I did for the data jam. New York City Parks, Beta NYC, the New York City Mayor's Office of Tech and Innovation, and NYC Open Data, Civic Hall, and Microsoft, and also Cartobee sponsored the all-day Data Jam event on Saturday, June 4th, 2016. I looked at challenge number 1, how has New York City's urban forest changed over time, and used Socrata to download the data. I scripted all of my project in Python with my settings py file with a bunch of dependencies and directory settings for the code, and then I read and munge my data in pandas to explore the variables. After I formatted all the CSVs, I used the CartoDB import API to import the CSVs into CartoDB. Shown here. And then I intersected the street trees for each census block, the NYC census blocks 2010. Again, using the CartoDB Python client to run the SQL query. And next, CartoDBified the tables and used the CartoDB SQL API to read the output right into pandas data frames. Next, I just quickly grabbed the NYC census block data, clicked the shoreline to get the shape area in square feet for New York City's local state projection system using dbfpy. And did some basic data carpentry in pandas to join the data on the census block ID, create some percent change metrics in street tree density per square mile. And then I import the master table using the CartoDB import API again. And then I merged those fields to the NYC census block 2010, clicked the shoreline geometries using SQL, and CartoDBified that table also. Next, I created some maps in the CartoDB platform using the wizard, some Carto CSS, and then set the info window to view all the street tree census variables across the census years whenever a census block is clicked. I created several CartoDB maps, saving each of them by copying the published viz's JSON URL. I then passed those JSON viz URLs into a Python script, along with some other information to generate HTML and JavaScript files using Python. I looped through lists and some HTML to generate the drop-down menu, the export buttons, and a variety of other map elements. Please note for this task, I probably should have used Jinja or some other Python tool. And then I write these to a GitHub Jekyll template I created quickly using Jekyll Ruby. So here we have the HTML files. You can take a look in Google Chrome. So here is the data mapped out. We have counts for 1995, 2005, and 2015, count of street trees per census block. And we also have the density of street trees per square mile in the census block for 1995, 2005, and 2015. Note in 2015 there are some areas that appear to have significant drop in the density of street trees per square mile, and that's likely due to the fact that the census is not totally finished. Okay, and then we also have percent change in street tree census density. So here we have 95 to 2005, pretty uniform distribution of the differences. But now from 2005 to 2015, we're seeing more targeted differences, also for the 95 through 2015. Now if we plot the counts of street trees per census block in 95, then also in the 2015 census, you sort of see that there's particular neighborhoods that appear to be sort of missing from the 2015 census. And that's most likely due because it's incomplete. can see some patterning here where we're seeing that there's not much of the 2015 street tree census completed. Another feature that I added was the ability to download the data that's seen on the mapping screen, either as a CSV. So here we see the block ID and also the variable that's mapped on screen, and as a shapefile. And this is using the CartoDB SQL API to download the data. And then we can open that shapefile in desktop GIS software such as QGIS, and then use this shapefile for anything we wanted to use in our desktop platform. The user can also access all the data by hitting All Data button on the website, and then download CartoDB using either CSV, SVG, GeoJSON, KML. And again, all my code for the data processing, for the website generation, and then again the Jekyll Ruby site is all on GitHub. Okay, thank you very much.